talking about Cipollino. We will be talking about power supply in simple words. We will not be talking about the famous fairy tale. We will have PT expert Yuri Vasin. He is here with us. And I'd like to note that at the stand of one of the famous software developers, Astrom Entertainment, there will be entertainment slots at 5 p.m., 6 p.m. and 7 p.m. There will be Warface competitions there. The winners will get awards. Do you play Warface? No? Well, please visit the stand. Nevertheless. And right now we are going to talk about Cipollino.
Всем добрый день.
Good afternoon, everyone.
Так.
Well,
Ну, маленькая связка с предыдущим докладом. Сейчас
probably to pick up from the previous presentation, in very simple words, I'll try to tell you about how chips get hacked,
проверок, шифрование, сбег.
that the chips that we use
О чем
to
касающиеся физики, схемотехники.
create keys with biometrics, without biometrics, simple or complex passwords. So I'll try to talk about all that in simple words. So, yes, it's the continuous process of creating things, hacking things, and I will talk about Cipollino later. And first, I'd like to explain what is power supply attacks and what is side channel attacks. Basically, that's an attack that goes through a side channel. It doesn't mean that you need to hack or break a thing. It means that you need to either extract information or impact the system. It doesn't mean that you will miss a check that will help you to get into the system. Side channel helps you to access the system or extract information from the system. Here I presented four main types of side channel attacks that we use in different labs, including in our labs. Out of these four types of attacks, you can see those in the Positive Labs tent in the closed area. You can visit it and find more information about that and actually see it with your eyes and touch the equipment. So first I'd like to talk about power attacks.
Следующее, что мы обсудим, это
The next thing we'll discuss is laser fault ejection. Basically, that's impacting the system with a laser, then using the electromagnetic induction to affect a chip, and probably the most complex method. It's not about impacting the system, it's about collecting data about the system. That's power analysis. So there, and I mean, after this presentation and several other presentations, you will be able to extract encryption keys from CPUs. But first, let's talk about what I've presented here. I'm going to talk about everything in the context of micro CPUs and microcontrollers, and you need to understand how they operate in order to understand how these attacks function. And I actually imagine everything as Henry Ford's conveyor. Talking about what side channels are is if you come up to one of the windows of Henry Ford's facility, and if you direct a beam of the sun to one of the assembler's eyes, then probably they will miss things. They either will make an error or they will miss something, will not check something. And that's what means not affecting the system, but nevertheless impacting it somehow in an indirect way. And that's what these attacks started with. CPU can be imagined as a conveyor, and any program execution functions like that for a code writer. That's execution of a code. For a reverse engineer, these are bytes.
Байтики, просто набор циферок.
And
Как-то интерпретировать, исполнять и что-то делать в зависимости от того,
every CPU interprets all these bytes depending on
вторую, третью команду и исполнять по очереди. Это
the value. And if CPU
система, и начали
processes
их внедрять везде.
these symbols, this code,
Этой циферки от момента, что вот цифра
by every bit, by every digit, then it would take a long time.
довольно много стадий для процессора внутри, которые совсем не явные. Ты отсюда скопируй в какое-то промежуточное
The processor decrypts this code to understand what it needs to do, what should be transferred and saved where, and then processor takes time to decode the code. So inside every processor, there is a conveyor that picks up the code
То есть команда может быть
and
потом это все дешифруется,
first
декодер.
executes this code. So there is a decoder first that decodes the code to
Нужный следующий шаг, чтобы он взял и
tune all the parts of
положил,
the microcontrollers
после чего это все как бы исполняется.
in components for it to be able to perform the operation. So it operates in this way, and this metaphor for conveyor is applicable. And once one operation is completed and the next operation starts, the next
Будет все равно делать дальше.
bit of the code is decoded, and the microcontroller starts thinking about what it is going to do next.
Система
So once we understand that this microcontroller is a complex system, there is this
то есть самый дешевый метод.
conveyor. The cheapest methods to affect it is a power attack. Every
3 вольта.
CPU, every microcontroller
Одна линия, две или три
consumes power, and usually it's through 1, 2, or 3 lines.
используются в области реверс-инжиниринга различные.
This attack method and this method
Исполнение
has been used by reverse engineers for a long time. And if during
на 2
executing an algorithm you cut the power for a tiny fraction of time and you bring it back, what happens? Well, what happens is a very good question. And my colleagues
произойдет. На самом деле
very often try to understand what actually happens. You can't know
какой-то сбой
it for sure when the system is closed. But anyway, you will have a disruption. But that is why we call these attacks
работы системы.
power attacks or a glitch.
Это самое
A glitch, which is a sabotage of the system's operation. So basically,
для того, чтобы
the transistor that you can control can be used to cut power when you need it.
обойти
When do we need it? When
единичную
we need to bypass or skip
противопоказания
one check.
защитились.
When, for instance, the system is not protected from this kind of attacks. Usually people use disruption of the main line of power supply that goes to the controller,
Для
or sometimes when manufacturers bring out power supply to
штука
add
необходимо
more components to this power line. The manufacturer, for instance, need that to optimize the distribution of components in the case, but that allows the attacking team to get
напрямую
to the system to attack it.
3 вольта. Вот эти.
And for instance, you can disrupt power supply
Бывает,
of
флеш-память
a core.
довольно много потребляет энергии, ей дают один.
Or, for instance, you can do that with flash memory. It consumes quite a lot of energy, and sometimes it is supplied with energy in a separate way. And,
Оттуда значение
for instance, sometimes
пароля.
you can opt to do that, especially if the microcontroller uses the flash memory core, and that method actually
Поговорим о самом дорогом,
had been the cheapest
но у которого
and the easiest
как бы он
to
дорог.
disrupt the operation of a system. And now we'll talk about a more complex way of affecting the system, and it does take some effort, but the effect is great in terms of time precision, in terms of positioning, and it's very difficult to protect yourself from it. It's laser fault injection.
в глазке, а можно посветить на конкретные
Going back to Henry Ford's conveyor and sending the beam of the sun to the assembler's eyes, but here you can send a laser beam to one of the parts of the controller.
находятся полупроводники и
And in this way,
энергия,
the
в принципе, какой-то заряд
energy is conveyed to the board directly.
ячейки на каком-то контакте
And the value of a certain cell within one contact can be changed from 0 to 1 or from 1 to 0, and that can cause disruption. And it's very easy to use that method to skip one of the
схему, ее в зависимости от ее
check stages.
надо подобрать
And in order to be able to do that, you need to open the case from one of the sides. You need to have direct access to that silicon plate,
делать
to the board.
снизу. Тогда
And basically, you need to have an opening, usually from the bottom of the board, and that gives you access to the piece of silicon.
процедура, ее можно сделать и дома маленьким таким фрезером. А
You
начинать
can do that with a simple cutting device and use a laser to shoot a beam
действовать.
into that component. You can do that in this way, but you can do it even better to have stable
Сделали, завтра можете повторить.
impact on that element. To be sure that you can repeat tomorrow what you did today, you need to control the thickness of silicon that
Утонить,
remains.
взять и сделать кремний тоньше. А это уже не
And it means that you need to
самое сложное.
make that
После того, как вы утонили, немножко
layer of silicon finer.
поверхность
And once you got it
лазер действительно
thinner, you need to polish
электронных структур,
the surface for laser beam to be able to
потому что
get through
способны, потому что кремний для инфракрасного
that layer of silicon.
практически прозрачный.
Silicon is almost transparent for the infrared beam, and almost means that it is not completely transparent. If it were transparent, we would just skip surface treatment, but here you need to do that.
200 000 рублей,
A
наверное.
laser, you can obtain it, you can buy it for 200,000 rubles, but still, to use this method, you need a lab, because you need to tamper with the case and you need to
Вы знаете, как это
prepare the case.
это уже
And then when you have the chip, when you have the laser, you can act in a manner very similar to power attacks. As a result,
для лазера.
you will assemble
То есть вы
a system that looks approximately like that for the laser field injection. So you make this window in the chip, this small square is the opening, and there you can see a tiny bit of silicon.
мы в инфракрасном диапазоне не можем.
However,
Но если сюда
It-
посветить инфракрасный,
you cannot
пронаблюдать
see it because it is only visible for the infrared and for a camera. But if you look at it through a device, you can see the microelectronic structure inside that
микромикронный момент,
black square.
осциллограф
So you have this construction with a chip, you send the laser beam
компьютера,
into the window, and you use the oscillographer to control what happens to the system or to interact with this chip during the attack.
и вообще стоит отметить, я так
And
для общего развития, что
it's worth noting, just for general information, that there are companies that used to produce, or maybe they still produce, complete system for that with a laser already
в рынке не купить, но когда-то было можно, например,
tuned to this kind of operations, and they were obtainable,
единичные
including on the Russian market.
покупают и используют,
They used to cost millions of,
когда
but for labs, people
и сложный токен
do buy the kind of units for their labs in order to be able to study the process
я
or to modify it. Now, going back to simple attacks, I already mentioned EMFI, that's electromagnetic impulse,
света,
that is used to affect the system. There you don't use light or laser, you use electromagnetic field to convey energy to the chip.
изменяет
From our physics classes,
проводник
we know that
ток,
the electromagnetic field induces electric current in conductors. So inside the microcontroller, in this way, you can change the value
ну, не магнит, а
of one cell
магнитным полем, которое изменится во времени.
if you
Система здесь очень
really
на самом деле
impose an electromagnetic field on that chip. And that system is very cheap. It works on basic physics. You need to
время, как
create
открываться и пропускать, спускать все это напряжение через которое
electric
большое.
current, and then you use a reel to create a large electromagnetic field, and the microcontroller should be placed next to that reel.
Здесь есть плюсы, что от этого довольно сложно защищать,
And
потому что
well, it looks like
непосредственно защищаются тем,
a simple thing, and it's difficult to protect yourself from this kind of attacks.
надо экранировать чип. Это
From
очень сильно.
other attacks, you can find protection means, but to be protected from EMFI, you need to have a screen, and it is very long to bring a microscheme
Можете, ну, если через год я
to the market. To get protection for that, usually it requires more than a year. When
на мой взгляд, очень серьезно.
it takes less time, I'm ready to applaud that.
На экране показано, она действительно должна быть большой геометрической.
And
И
in terms of the drawbacks
само воздействие
of this process, the reel should be quite large in order to create that
точности говорить не приходится.
reel. So this technology lacks precision, but inside our our laboratory, we do have positive results working with this technology. So you can go to our lab and see how it works. There is a reel there, and it gets discharged above the chip, and its behavior changes. So you can see all that. And wrapping up,
По питанию, а это уже power analysis.
the next thing is not about power attacks, it's power analysis rather, and
Это является
it's worth your attention. This interesting method is really at the cutting edge when these blue and red teams compete. We are
ничего.
at the point when probably in a couple of years we will not be able to do anything without power analysis. Even the popular controller ES32 is susceptible to power attacks, and it is only susceptible to this kind of attacks because it is protected from other types of attacks. So, power analysis. What should be done there, and what examples can we cite? Here we do not
Опять же,
affect the system. We collect information about the system. In terms of power, what can be collected? We can look at power consumption, at the power consumption by the microcontroller within certain spans of time.
во всех умных домах
P32 is one of the most popular chips that is usually used for smart home systems, and quite recently they got this option, encrypted boot. That's decryption
ключи
of the system
в памяти,
during booting using some keys, and these keys are hidden in the memory and they cannot be accessed from
которые уже внутри.
programmator apart from the programming blocks inside the microcontroller.
Руками
So you can
прошивку, но это будет
try and do that manually and read the system data.
А учитывая, что эту прошивку микроконтроллер сам
That information will not be very useful.
то кажется,
And considering that the system information can be read by a microcontroller on the go, it looks like
цифровки как-то анализировать.
in order to obtain this information
Power analysis, то есть берем
during that process, you need to somehow read it. So we use power analysis for that. We take an oscillographer, and the chip is
записывается трасса,
switched on and off many times. And this track
где написано good, это
is read
питание в момент расшифровки
and registered. So
весом ESP32.
you see at the picture,
Тут тоже думать надо.
sound is good.
Картинки как
is the process of decrypting this information
Вы не знаете, хороший,
from AES.
набравшись опыта,
And the bad example,
и плохая.
well,
Наберете плохие,
right away you can't say whether it's good or bad, that after some time you will see
если вы соберете
which one is good and which one is bad. But after some time, when you collect enough examples of good readings and bad readings from good readings, you will be able to extract information. What makes this information accessible? During decryption, that's a complex process. There are many triggers, many transistors inside the microcontrollers that get switched on and off.
зависимость.
And if you find the dependency, for instance, between the input data that processor uses for decryption and the information on the power
В данном
track, then you will be able to use all that information to recover some data. Usually we recover keys for AES that is hidden inside the controller. For that we use the function of correlation. And behind me you can see this function of correlation. Well, basically it's the function of, it shows whether there is some dependency, some correlation between one and the other. And if you analyze, if we capture many
корреляцию для всех этих зависимостей.
tracks, and if we calculate the correlation, this dependency on the input data from these registered data,
Признак
then you'll see these peaking values. And these peaks show us that there is a leak of power
и как-то интерпретировать
that later you can treat and interpret. This peak
какие-то трассы
says that you capture not only just some
по работе
tracks,
контроллера.
but that this track contains information about how microcontroller functions. So I'm not going to make it more complicated. The only thing I want to add is that the Positive Labs tent is over there. You can go there and see and touch things for yourself. And here's the useful links. Yuri Vasin, Positive Technologies. Well, that's the case when even my brain, that is used to treating lots of new data, it
Да?
А мне же приходится
pleads for mercy.
Рассказывай, чтобы что-то было понятно.
And just imagine what it takes to actually speak about that.
Даже
Well, you know what
токены, их можно взломать.
a layman can say that actually this technology is wonderful. Even power supply tokens can be hacked, and that makes us vulnerable. And that's a very good lesson for anyone who's interested in cybersecurity, because you can get attacked at any point. It gets more expensive and more complex, but still.
Васин,
Thank you so much.